So in the early part of this section, we talked about naming ionic compounds. Now we're going to talk about naming molecular compounds that have covalent bonds. And on the last test, we had the question about the difference between ionic and covalent bonds. And most of us said things like ionic bonds are metals and nonmetals. Covalent bonds are nonmetals. So as you see in these examples of molecular compounds, we're looking at all nonmetals bonded to each other. So we also have a stock system for naming compounds, molecular compounds. Bless you. It's really just based on a set of prefixes. So, for instance, carbon tetrachloride, where tetra would mean 4. We've discussed that before. Carbon monoxide, where mon means 1. And carbon dioxide, where di means 2. Notice how when the first element only has 1, we don't write monocarbon, we just write carbon. However, we will need to put a prefix in the first word if it has more than 1. Exactly. If it was C2O, we'd call that dicarbon monoxide. The other thing, notice that we are still changing the second word to "ide," so change that last syllable to "ide" in your second word for the second element. But here are some examples just to get a feel for these prefixes. And you'll either have to memorize these or write them down on your note card, because I don't have a reference sheet for you or anything for these. But mono means 1, so example would be carbon monoxide. Di is 2, so like silicon dioxide. Tri is 3, something like sulfur trioxide. Tetra means 4, so sulfur tetrachloride. Penta means 5, so antimony pentachloride. An example of 6 for hexa would be cerium hexaboride. Hepta means 7, so that would be iodine heptafluoride. Octa means 8, so notice like we were saying, in the first word here we do have to put the tri in front. So it's going to be tri-neptunium octoxide. Nona means 9, so tetraiodine non-oxide. And finally, deca means 10, so disulfur decafluoride. And just to remind you the difference between ionic and covalent naming. For ionic ones, we just slap the two names together, changing the second word to "ide." But now for covalent, where we're dealing with, or molecular compounds where we're dealing with covalent bonds, things like dinitrogen monoxide. We've seen carbon tetrachloride a bunch last chapter. Phosphorus pentafluoride. And I don't like this example because I think this is a metal and a non-metal. But if it was named as a covalent bond, it would be trilithium nitride. So do you see how that naming system works? We don't want to put the mono in the first word, but everything else, we're going to just put the prefix in front and change the second word to "ide." Any questions on that? So let's try a couple examples then. What would the element As be on your periodic table? Yeah, arsenic. And do I use the prefix for arsenic here? Yeah, let's make it diarsenic. And how about the second word? Pentox. Yeah. Sometimes if it's awkward, like pentaoxide would be a little bit awkward. Sometimes we can cut off that last letter there and just make it pentoxide instead of pentaoxide. And then looking at can we go backwards and name oxygen difluoride? Can you tell me its symbol? Close. F. Fluoride is just F. So it's just going to be OF2. Florida. I don't know if there is an element. FL. Maybe Flavium. Let me see here. Or it's this one here. Fluorovium is FL. The other thing I wanted to point out is that sometimes you might wonder, well, I've got two nonmetals. You know, with ionic compounds, I know to put the metal first. What do I do for covalent? How do I know which one to put first? Well, typically the one to the left is going to go first. So since oxygen came to the left of fluorine, we put oxygen first. If it would have been, that's why like with N2O, dinitrogen monoxide, we put the N first because N comes first on the periodic, to the left on the periodic table. So any questions on either of those two? I hope it's simple enough for you. Some more examples. Sometimes you might have noticed with building the molecules, you could at times keep going and going and going because similar to ionic bonds, there are some covalent compounds that exist more as a 3D network versus just a singular molecule. And again, we're just going with the simplest ratio. So make sure you update this in your notes that there was a typo there for SiC, but it should be silicon monocarbide. SiO2 would be silicon dioxide, and then Si3N4 would be trisilicon tetranitride. So again, just adding that prefix to the second word, and if the first word has more than one, we'll add that there as well. So that's covalent compounds. That's really all I'm going to be quizzing you on. But I do want to at least give mention to acids and salts because sometimes acids will show up on different worksheets that I give you. So I'd like to at least preview you on the names for these. We'll talk about acids more in Chem 2. But an acid is a certain type of molecular compound. They're either going to be binary acids, meaning that they only have two elements, or they're going to be oxyacids, meaning they have hydrogen, oxygen, and another element, usually a non-metal. So some examples could be, for binary acids, we have HCl, HF, so hydrochloric acid, hydrofluoric acid, hydroiodic acid. Notice when it's a binary acid, I say hydro, and then the element, and then I add IC at the end. For oxyacids, something like this with a sulfate ion, we would call that sulfuric acid, or
So hydrochloric acid would be like hydrogen chloride.
exactly. So according to the covalent bond naming system, we would call that like hydrogen monochloride. But usually, notice what do you see the pattern for all these acids? What kind of stands out to you? Yeah, the H, usually when you have an H in front, you're looking at an acid. So that's typically when you wouldn't use our normal covalent naming techniques. Just to kind of get you used to that because it comes up. We've used hydrochloric acid in the lab, so it's good to know. And you know when we use that hydrochloric acid, we weren't using the actual powder of it. We had it diluted to a degree, and we even used different strengths of it, different molarities, concentrations. One thing I want to point out is a lot of polyatomic ions are produced when we lose a hydrogen from the acid. So like the sulfate ion could come from sulfuric acid, these polyatomic ions. And notice when I have an 8 there, 8s always end in IC for the acid. So nitrate would be nitric acid. Phosphate would be phosphoric acid. To define a salt, we've neutralized some acids before. Basically, when I take an acid and a base and neutralize them so that I get either water or, in this case, hydrogen gas, the other substance that's left behind is going to be a salt. When I take hydrochloric acid and sodium hydroxide, let me write this out here. When I take HCl and NaOH, what happens is the H and the OH recombine to become water, and the Na and the Cl recombine to become sodium chloride. So anytime I'm doing a neutralization reaction, the part that I get that precipitates into the solution is going to be called salt. That could be many different things. But we'll talk about that more in Chem 2. Lastly, I just want to show you how the naming works with a polyatomic ion we've looked at before. If you remember, with chlorine, we can have 1 oxygen attached, 2 oxygens attached, 3 oxygens attached, or 4 oxygens attached. The naming goes from, we start at hypochlorite, and then just chlorite. And then we go to chlorate and perchlorate. So those are what we should know from my periodic table of ions, what those ions are called. And I just want to remind you that the 8 suffix will turn into ic, and the ite suffix is going to turn into OUS. So when I name these acids, whoops, that's not what I wanted to do. When I name these acids, it's going to become perchloric acid. Notice that hydrogen is added to all these. This is going to become chloric acid. This would be, because of the ite, now it's chlorous acid. And then again, ite, this would be hypochlorous acid. So you kind of get the idea, hopefully, on how the polyatomic ions change from 8 or ite to IC or OUS. Again, we'll go over that in more detail in Chem 2, but I just wanted to give you a little preview in case an acid happens to show up on one of your worksheets. But there are different rules to naming acids and covalent compounds, molecular compounds. So does anybody have any questions about any of those naming techniques? I do have a homework assignment up there for you.